Determine the locus of the midpoint of a rod of length L that slides with its end on two perpendicular lines. Let us begin. So here, we'll start with the case here that it's given here that there are two perpendicular lines. The rod of length L slides with its ends on those two perpendicular lines. For the ease of solving this problem, we'll consider the two axes at the x-axis and the y-axis because they are two perpendicular lines. So here we have the x-axis and the y-axis that they're perpendicular to each other. Now what we'll do, we'll suppose that we have a rod of length L and it is going to slide with its ends on those two axes. Now let's imagine that the one end of the rod which is touching the y-axis meets at the point A having coordinate 0, A, and the other end of the rod meets the y-axis at the point B with the coordinate A, B, 0. Now this particular rod is sliding, that means A is going downwards and B is going to the right side. Our goal will be to determine the locus of the midpoint. So let's say this is the midpoint, this particular region is the midpoint, and we're going to name it as point P with the coordinate H, K. Let's begin. Now we know that the midpoint P is going to divide the rod AB into the ratio 1:1. Now since it's dividing AB into ratio 1:1, we can use the section formula to obtain the coordinates of point P. So let's do that. So we'll begin with the x coordinate. So the x coordinate will be given by, so we'll have to take 1 and multiply it with B, and this particular 1 will get multiplied with A. So that means we have to find out the x coordinate, we'll multiply 1 with the x coordinate of B. So we have 1 times B added to, next we'll multiply 1 with the x coordinate of A, so that's 0. We have 1 times 0 divided by the sum of the ratios, so that's 1 plus 1. Next, to find out the y coordinate, we'll take this particular 1 and multiply it with the y coordinate of B. So we have 1 times 0 added to it will be 1 times the y coordinate of A. So we have 1 times A, and this will be divided by 1 plus 1. And that means we now have B over 2, A over 2. So that's going to be the coordinate of this particular point P. Since they are equal, so what we'll do, we can equate them to get H equals to B over 2 and K will be equals to A over 2. And if we want to express A and B in terms of the respective H and K values, then we can say that B will be equals to 2H and A will be equals to 2 times K. Fine. Now, what we'll do, we'll consider the triangle OAB. Now clearly it's a right angle triangle. Now what we'll do, in right angled triangle, we'll consider the triangle AOB such that it is right angle at O. So here we can use the Pythagoras theorem. So we have OA squared plus OB squared. This will be equals to AB squared. Fine. Now what's OA squared? OA squared is the distance between the origin and the point O. Now we can easily use the distance formula. So here we have the difference of the x coordinate. That's, so what's the coordinate of the origin? That's simply 0, 0. First we need the difference of the x coordinate. So that's 0 minus 0. We're going to square it and then add it to the difference of the y coordinate. So we'll take A minus 0, square it. So this is the length of OA squared. Then we will go to OB squared. So here we'll first take the difference of the x coordinate. So we have B minus 0. We are going to square it and then add it to the difference of the y coordinate. So that's 0 minus 0 squared. This will be equals to AB. AB is nothing but the rod. The rod has a length of L that's already provided to us. So this will be simply equals to L squared. Now that means we will now have A squared plus B squared equals to L squared. Now we have already defined the value of A and B. We can replace the value of A with 2K. So we get 4K squared. And the value of B with 2H to get 4H squared. So this will be equals to L squared. So let's rewrite it. So we have H squared plus K squared. So this will be equals to 1 over 4 times L squared. And we will finally replace the value of H with X and the value of K with Y. And this is going to give us the equation of the locus of the midpoint. So we have X squared plus Y squared equals to 1/4 of L squared. So this is the locus of the midpoint of the rod of length L which is sliding with its ends on two perpendicular lines.